Welcome back to the channel. Today we'll be solving final maximum sum of node values. It's labeled as hard questions, but I actually found a way to work around this without using DP or anything that's mentioned in the editorial. Let's just start with reading the problem. So there exists an undirected tree which n nodes, number from 0 to n minus 1, and you also given edges where they give you u and v, indicating that there is an h between them. So you're also given a positive integer k. This is used for you to perform the XOR. So Alice wants the sum of the values of tree to be maximum. So Alice can perform any number of operations using any number of times of that to the tree. So you can choose any h, u, and v connecting the nodes, and then update it by using nums of u equals to the nums of u XOR k, and the v also XOR k. And then you want to return the maximum possible sum of the values that Alice can achieve. So the given example is like this. So you have h connecting 0, 1, and 0, 2, and then you want to XOR them, the case is 3. So if you XOR the 1 and 1, so you would get 2. So this turns to be 2. So you get 2, 2, 2, it becomes 6. So one thing I actually found is that, let me get to my PowerPoint. So one thing I found is actually, if let's say I don't have the nodes between 1 and 2, and what if it happens that if I XOR this one and this one, will give you the maximum sum, right? Let's say this is the case where we want to flip XOR this and this. So what we can do is we can XOR this first. So 0 will XOR which k, and then 1 will XOR which k. And then this and this, then we XOR it again. So this will bring it back to what original number is, and then we can XOR this. So I don't think the edges really matters right here, because if you can perform any time, that you can connect this with someone else which is even number of time, and then they will just cancel out. So in this, my solution is completely ignore the edges, and I'll show you how. So what we need to do is that we can count how many times we have a positive count, right? So let's say in this case, 1 XOR 7 is equals to 6, 9 XOR 7 is equals to 14, and then 17 XOR 7 is equals to 22, if I remember correctly. So we can see that this is a +5 gain, +5 gain, and +5 gain. So each of the time we do an XOR, this thing will gain +5. So since they're equal, and then the sum of this should be 27. So and our constraint is that we can only do even number of times, right? On an even number of nodes. Not even number of times, even number of nodes. So this is a pair. This is called 1 operations. So we can +10 right here. We can add this here. And then we don't have a +5. We don't have another pair of nodes to do this. So we just have to drop this. So one way of thinking about this is you can do something called positive count. So you keep track of how many positive count you have, right? So this one, we have 3. So if this is not even, then we want to minus this one. So we can do a total diff to sum up what this is. Like total difference you gain to sum up with this. And then if it is even, we can just take everything. But if it's not even, then we want to minus the minimum one. So let's say if this is +4, then we just want to drop it, right? Because we can only do the even number, right? But what if we now have we have 4 things, but we really want to take into account. So in this case, 1 XOR 7, 9 XOR 7, 21. Oh, sorry, I meant to do 12. 12 XOR 7 and 17 XOR 7. So this will give you 11. This we found this already before. So this will be +5, +5. This will be -1, and this will be +5. So in this case, we actually still want to XOR this, right? Because if we just like do this, then we only have 10, right? We only have +10. So if we sum up this, I think we'll get 39. And then we plus 10, we only get 49. But if we flip these two as well, seeing them as a pair, we flip them, we get another plus 4 right here. And then we actually want this, right? So there's a way to work around this is we use some variables called minimum absolute difference that we found. So if we somehow find the positive, like positive count, right? We somehow find a positive count, it's odd, right? If somehow we find a positive is odd, we can just subtract the minimum absolute difference. Because if we keep the minimum absolute difference, this will be 1, and this will be what we're subtracting. Because if we add this on, we have to take it down off because it's negative, right? This is not actual like positive difference. So this is just something to work around with this. I can show you the code so it will be more like clear. Right. So at the first step we say is we want to actually calculate the sum of our current sum already. So if we can sum over all the values that we have, then we get that. And then total difference, it's just like what's a gain, right? For each one, if we have plus 5, then it's plus 10. The total difference will be 10. And then we also use the positive count to count how many positive values we use. And then for the mean absolute difference that I set, we set this to be infinity number for now, right? So what we need to do is just we need to go through all the numbers, and then we find a difference. The difference will be the XOR to k and then minus number. So what happens is if we find a difference, if the difference is greater than 0, then we add the difference. And then since this is a positive difference, we add our positive count by 1. Then here comes the trick, which is the minimum absolute difference thing I said. So now we can update our minimum absolute difference, which the absolute is different. So what is it saying is like, let's say we have plus 5, and minus 1, right? So since this is a positive count, it's even. So even though we add this to be 1, it doesn't really matter because we're not going to take this off. But this happened in the case where if the minimum absolute difference is very low, like the plus 5 and minus 1 case, and then we have an odd number or positive count, we actually want to take away that one. Or like if we have plus 5, and plus 2, right? Let's say our positive count is 3. So let's say in another case where we have plus 5, and plus 2. Then since our positive count is also odd, so we want to just drop the minimum one, right? So if this one is a minus 1, then we know that we can include this. So we're not actually dropping it, we just do a minus 1 because this is a minimum absolute difference. Let's say we have plus 5, plus 1 and minus 3, right? So in this case, we are just dropping 1 because we don't want the minus 3 to bring everything down. So this is just the high level logic. So next step, it's like after going through everything, we just want to do the positive count as we mentioned before. If it's 1, then we just want to minus from our total difference. And then in order to get the maximum sum, we just need to use our total, which is the original number we have, plus the total diff. Yeah, I think the key idea here for this question is just you need to realize that the edges given doesn't really matter because you can work around with flipping it multiple times, and then the XOR will just still give you the same answer. And then the minimal absolute difference is definitely something you need to think about on how to work around to remove it. Like whether you want to flip something, even though it's negative, it still will pair up with something else like a plus 5 and minus 1 will still give you a plus 4. And that's how you want to keep track of the absolute of the difference, even though it's negative. For this runtime, I would say calling a sum is O of n, and then going through all the numbers is O of n. So I don't think I used any other additional data structure, so this will be O of 1. If I go through this editorial, most of them have a time complexity of O of n and space complexity O of n. They're using DP, and I do not really know if this will be easier, but I definitely think my solution here it's more understandable. Yeah. All right. Thank you for your time. See you in the next video.